So, you're a Unix/Linux veteran, but do you truly understand kernel security? In this video series, I'll present to you a brief introduction to kernel security so you can finally fulfill your destiny. In this video, I'll be teaching you what the junk really is virtual memory, which is if you're familiar to C or C++, you might know the pain in learning it. But don't you worry, you're in the hands of an expert, and that expert would be me. Before we start, make sure you have a Unix system running and also a brain. And with that being said, let's get started. Before we learn about virtual memory, the first question one might ask is, why do we even need virtual memory? The simple answer is, most of us are running some crazy old Toshiba laptop, and like the Chads we need to learn Linux security. So, we do what any ordinary person will do and download VMware or VirtualBox and download Linux on it. But if you have limited hardware power to share, chances are you can't really make a VM. So what is the solution? Easy, we introduce virtual memory. It goes deeper than that, but this is what virtual memory does in a nutshell. So now that we know why we need virtual memory for a system, let's see what virtual memory really is and how to visualize virtual memory in your GNU/Linux system. So here's a nice illustration I found online. So you have your CPU, and inside of your CPU, your central processing unit, you have your random access memory. And RAM is intrinsically a physical storage system. It's your random access memory. So you can measure it, you can look at it, and etc., etc. But it's only a finite amount. So 16 gigabytes, 32 gigabytes, 64 gigabytes, and even 128 gigabytes. So RAM is in a limited amount. But virtual memory, as we're going to get to it, can be anything. Of course, it has a range, and I'm going to talk about that, but it's more or less restricted than the RAM, because the RAM is physical and virtual memory is, of course, virtual. So let's look at this illustration again. So you have your RAM, and your RAM takes a portion of data, less used data, and it sends it to the hard disk. Then your hard disk allocates some amount of virtual memory, and then it sends all that virtual memory to the amount your CPU requires. So let me go over this again. Your RAM sends a portion of data. Your hard disk sends a lot of data that your CPU requires. So for example, I give you maybe a quarter of data. Then you, in exchange, would give me about $5 worth of data. So that's basically what it means. So virtual memory is just an exchange for a little bit of your physical memory. You exchange a lot of memory in terms of virtual memory, of course. So you trade physical memory for virtual memory. So why do we even need virtual memory? So like I told you, you need virtual memory in order for your system to run. So basically, it's a memory management system that your system needs to run. So idealized abstraction of storage resources that are actually given to your machine. So if you do a certain amount of process, your disk sends a certain amount of virtual memory to execute that process. So now you might ask, how do I visualize it and how do I attack it as a kernel exploiter? Now, I'm going to do a video on that in the future, but for now, I'm going to show you how you can sort of go about attacking it and how you can visualize it. So here is a Debian system in VirtualBox. It's a virtual machine. So right now, I'm using a certain amount of virtual memory in order to run this virtual machine. So I'm going to do the command vmstat, and this should come default in all GNU/Linux systems, so you don't really need to install it. And then now I'm going to visualize this in terms of a table. So you just need to type -s switch. So vmstat -s. So this just says virtual memory statistics -s. And let's hit enter, and here we go. All right. So we have all the virtual memory that's being used, and this is in kilobytes. And here's all the amount of virtual memory being used in the current system. So this is really nice, and I want you to play around with this. I'll have a link down below on vmstat documentation. And now, how do you go about attacking it? How do you go about attacking your virtual memory? So the first thing that we need to know is your computer architecture can vary the amount of virtual memory there is. So for example, if you're running a 32-bit architecture CPU, then the range of the amount of virtual memory your system can allocate ranges from 0 to 2 to the 32 power minus 1. Okay? And if you're running a 64-bit, then it would be 2 to the 64 minus 1. So that's the range. So if you have maybe an advanced architecture system, it would be harder to attack it because of more virtual memory, right? More data stream, much faster processor, etc. So now, how do you really attack it? So let me go back to that illustration we just saw. And basically the way you're going to attack it is you need to keep your kernel and your processes very separate. And if you've seen that Linus Torvalds interview, it's like quite old. He explains to keep user space and kernel space separate. But here, it's quite the opposite. It's not quite the opposite. It's sort of the same thing. You need to keep processes and kernel separate. So for example, when your RAM sends less used data into the virtual memory, you as an attacker can intercept this right over here, and you can take that data out and use it as an attack. So you don't understand how dangerous that is. If somehow you were able to read the hardware to this low level, you can get a lot more information than you could possibly imagine. Basically, this is a quarter or maybe how much amount of data of your RAM. So for example, let's say you're loading in picture in the kernel space. You can intercept that data and you can get a little bit information of that picture. You don't understand how dangerous it is, and I'm going to go over how dangerous this is in my next series of videos that is about to come in this playlist. I hope you guys are looking forward to it, and I had a lot of fun making this video. It's been really a fun ride, and I hope you enjoyed it, and thank you.
I do in the kernel, and I have to fight this every single release, and I think it's sad. We have one rule in the kernel. There is one rule. We don't break user space. Everything else is kind of a guideline. The whole security thing, it's a guideline that we shouldn't do stupid shit, right? But that's not a hard rule. People do stupid shit all the time. I don't get that upset. People break user space. I get really, really angry. I mean, this is something that is religious for me. You do not break user space.